The significant issue regarding the quest for extraterrestrial intelligence is that despite extensive efforts, we have not definitively encountered any evidence of it. Throughout our exploration of the cosmos, we predominantly encounter celestial bodies like stars and nebulas that exhibit natural characteristics, offering no indication of alien influence. Essentially, this galaxy appears to be an expanse of unclaimed territory, seemingly untouched or utilized by any other civilization. Despite its age allowing for multiple colonization opportunities, the galaxy's age suggesting the potential for numerous civilizations to have emerged. The Fermi Paradox confronts us with the question, where are the aliens? Various explanations attempt to tackle this paradox, with some offering benign possibilities, while others propose more disconcerting and unsettling solutions. Here are 10 disturbing resolutions for the Fermi Paradox. 10. The ultimate consequence of existence appears to be technological seclusion in philosophy. There's an ancient concept known as the brain in a vat, illustrating the notion that if your brain were isolated in a container receiving sensory input through wires, you'd be unaware that your perceived world isn't genuine reality. As virtual reality advances, this concept gains a new dimension, potentially reaching a point where virtual reality becomes indistinguishable from actual reality. This poses a dilemma for civilizations, since virtual reality allows customization to an extent that actual reality cannot match. It could create paradises or fulfill any desired fantasy. Without the constraints of physical reality, individuals could inhabit chosen fictional worlds, battling dragons or exploring the cosmos and bound by the limitations of light speed. Even the emulation of other individuals becomes theoretically possible. In essence, perfection in existence could be attained through virtual reality. In such a scenario, there might arise a disregard for actual reality. The question emerges, why bother with genuine reality if an alternative offers perfection? Could there be a risk of forgetting that reality exists? Setting aside whether humanity would pursue this path, extraterrestrial beings might opt for it. Could it be plausible that the absence of evidence of distant alien civilizations is due to their technology, providing a superior alternative to genuine reality? Perhaps they never venture beyond their home planet simply because they lack any incentive to do. 9. The cosmos is fabricated. The concept delves into simulation theory, suggesting the possibility that our existence might unfold within a sort of universal virtual reality, albeit one far removed from any utopian vision. In this scenario, if we indeed inhabit a simulation, the solution to the associated Fermi paradox suggests that we intentionally stand as the sole sentient artificial intelligences within this constructed matrix with no other inhabited planets across the expanse of the universe. However, this premise raises a profound question: why does the universe exhibit such immense scale? In contrast to our limited perception of it, countless galaxies, regions so distant that they elude our observation. Why would a simulated environment encompass such vastness, most of which we may never explore? The purpose behind crafting an expansive simulated environment that exceeds our ability to explore. It remains an enigma, a question waiting to be unraveled. 8. Extraterrestrial beings exist ubiquitously yet remain unseen. The challenge with the search for extraterrestrial intelligence lies in the multitude of assumptions it requires. Presently, our primary approach involves listening for radio signals, assuming that aliens might employ such means of communication. However, this assumption stems from our own civilization. The only example we have, the truth is, we lack understanding about how aliens might communicate. Our history with radio communication doesn't strongly support the notion that an extraterrestrial civilization resembling ours would use radio for contact. Most of our everyday radio signals remain undetectable over long distances, even the detectable signals, such as various messaging to extraterrestrial intelligence transmissions like the Arecibo signal, or radar, don't exhibit the anticipated repeating patterns of an alien beacon. Consequently, our civilization would be incredibly challenging for aliens to detect, and even if they did, it would likely extend only around 100 light years. Thus, the query arises, why would other civilizations be any more conspicuous? Moreover, there exists the possibility that highly advanced civilizations employ communication methods beyond our current conception. They could be present all around us, engaged in discussions, unbeknownst to us until we uncover these methods ourselves, revealing a vibrant galactic dialogue. Consider the potential scenario of them discussing our existence without our awareness. 7. Humanity has hit the jackpot for the time being. This concept, often termed neo-catastrophism, suggests that the absence of evidence of alien civilizations stems from their frequent resetting by natural occurrences before they evolve into advanced spacefaring societies. Numerous possibilities exist for such resets, ranging from asteroid impacts to devastating gamma-ray bursts. In our case, luck has been on our side, although our planet has endured its own share of catastrophes like the asteroid impact that wiped out the dinosaurs, an event that, had it been slightly more severe, might have eradicated most complex life forms. Yet this mass extinction paved the way for mammalian dominance and eventually the emergence of humanity. However, as lotteries illustrate, winners are far outnumbered by losers, and this could hold true for the galaxy as well. The question remains, have we truly struck it lucky? Or are we merely biding our time until nature's own forces lead to our extinction? Yet, an intriguing aspect of this solution emerges over time. The suggestion arises that as stellar evolution progresses, occurrences like gamma-ray bursts might diminish, potentially reducing natural catastrophes in general. If this hypothesis holds, it could pave the way for a surge in complex life throughout the galaxy. Perhaps we exist either too early or at the cusp of this phase. 6. Alien life forms demonstrate excessive aggression, hindering their prolonged existence. Aliens potentially face a significant barrier to long-term survival due to their inherent violence. This notion aligns with various solutions posited within the context of the Fermi Paradox, suggesting a series of obstacles that halt civilizations from advancing beyond a certain stage. In this scenario, the stumbling block might be present within our own civilization. The prospect of self-destructs. Human history reflects a checkered past when it comes to warfare and violence. Our capacity for both restraint and unspeakable horrors exists, alongside the means to annihilate our own society. To our credit, we've thus far avoided such a fate. But ponder what this implies for extraterrestrial civilizations. Violence isn't exclusive to our species. Observing a polar bear hunting and consuming prey showcases nature's brutality at its apex. Yet, for the bear, this is a necessity driven by evolution. Similarly, in the larger universe, complex life, if present, likely reached its status by consuming other life forms. While a significant portion of humanity can harness reason to control aggression, substantial resources are allocated to defense. We can negotiate peace or choose conflict based on reason or impulse. However, consider the implications if we were slightly more inclined toward aggression. Akin to the polar bear's instincts, such tendencies could result in a calamitous outcome, possibly inhibiting the development of a civilized society. It's conceivable that alien species might be more inherently aggressive than us, especially if their world presents challenges in obtaining sustenance, potentially driving the evolution of heightened aggressive tendencies. Could a level of aggressiveness be a prerequisite for venturing into space and expanding across the universe? This perspective suggests that alien civilizations might be preoccupied with internal conflict rather than space exploration, leading to their eventual self-destructs, hopefully. As a species, we demonstrate a more promising outcome than this. 5. Sentient life within the cosmos is remarkably scarce. Intelligent life within the universe might be exceptionally rare, as Arthur Clarke contemplated the idea that we're either solitary in the vastness of space or not, both notions equally daunting. But what if intelligence emerges only sporadically? Perhaps once every few galaxies, there are grounds to consider this possibility. Consider Earth's circumstances. What precise factors converged to enable our existence, the planet's size? Life evolving in a manner conducive to oxygenation. Plate tectonics, the carbon cycle, the presence of the moon. Liquid water, Jupiter. And numerous other elements had to align just right to foster our civilization. Does this make Earth incredibly scarce? Are planets mimicking Earth's conditions almost exclusively capable of nurturing civilizations? We're left questioning whether the vastness of the universe might harbor numerous civilizations, yet the staggering distances between them inhibit communication for billions of years. Or perhaps indefinitely, could existence remain confined within individual species due to these immense separations, leaving us perpetually pondering whether we're truly alone? Amidst the ever-expanding, desolate cosmos, nevertheless, there's hope. Some speculate that planets might exist even more conducive to nurturing intelligent life than Earth. Additionally, if extraterrestrial life isn't found within our galaxy, there's the potential to create our own. Colonizing the Milky Way, something I'm optimistic about, could happen within relatively short geological time frames on the scale of millions rather than billions of years. Eventually, these human colonies might evolve to such a degree that they become akin to aliens themselves. 4. Temporal dimension. When contemplating alien civilizations, we often focus solely on distance, pondering the vastness that separates us. However, there's another dimension at play that could render civilizations scarce: time. The alignment of existence between civilizations within a galaxy isn't guaranteed, especially if technological societies endure only for a few million, thousands, or even hundreds of years on average. The Milky Way, given its age, might have previously harbored civilizations that no longer exist. We might endure as a civilization for millions of years, but eventually face extinction in the distant future, allowing a subsequent species to rise and possibly uncover remnants of our existence. The crux of the solution lies in civilizations being rare, yet not exceedingly so on geological time scales. Therefore, the Milky Way, over its existence, might have accommodated hundreds of civilizations, albeit rarely coexisting. This scenario implies that the galaxy could be replete with remnants or artifacts for us to discover. But what if we encounter an artifact responsible for a civilization's demise? 3. The zoo theory. The zoo hypothesis presents a straightforward solution: extraterrestrial beings exist, are aware of our presence, but intentionally conceal themselves from us. Several reasons could underpin this behavior. Firstly, they might be waiting for an opportune moment in our evolution to reveal themselves, opting to observe and gather information before initiating contact. Conversely, they might harbor fear or apprehension toward us, maintaining secrecy to either unexpectedly eliminate us in the future or restrict our advancement in interstellar travel. A particularly eerie prospect within this hypothesis is the potential for all species in the galaxy to be held captive by a superior species, possibly the first to emerge within the Milky Way, adding to the distress. Imagine if this ruling entity were a machine civilization controlling and subduing the biological life forms. 2. The resolution for sustainability. A recent addition to Fermi Paradox solutions. carries substantial implications for our civilization and potentially the entire galaxy. The absence of evidence regarding alien civilizations colonizing the galaxy might stem from the likelihood that doing so leads to the inevitable collapse of one's own society. In a paper authored by Jacob Hack-Misra and Seth Baum challenging conventional assumptions, they contest the notion that civilizations expanding through the galaxy would do so exponentially a projection based on human expansion on Earth. However, history reveals instances of unsustainable practices leading to collapses in human populations and civilizations. This implies that our collapse might occur even before we fully colonize our solar system, or possibly afterward if we mismanage our resources. Such challenges might extend across the galaxy, suggesting that civilizations failing to responsibly manage resources and opting for exponential expansion tend to face collapse. Conversely, civilizations taking a slower, more deliberate approach might not have had sufficient time to extensively colonize the galaxy. The pivotal question remains: what choices will we make? Curiously, despite vast distances to neighboring and faraway stars and the apparent lack of feasible, faster-than-light travel, our progress may remain sluggish. Hence, the solution to the Fermi Paradox might be that rapid expansion is inherently challenging, leading other civilizations to maintain a relatively limited scope, at least for the time being. 1. Perhaps the Fermi Paradox doesn't truly constitute a paradox. The fundamental premise behind it suggests that, on the surface, the numbers should logically yield evidence of alien civilizations, abundantly sprinkled throughout the cosmos. This notion gains support from concepts like the von Neumann self-replicating probe, theoretically capable of populating the entire galaxy within a few million years, placing probes in every star system without surpassing the speed of light. However, why hasn't anyone executed such a venture? There remains the possibility that it's already happened, but we lack the means to perceive it. If a von Neumann probe, or several were stationed in our star system, unless they emitted conspicuous signals of their existence, they might go unnoticed. They could lie dormant, periodically collecting data across millions of years, or be extinct, awaiting discovery by spacefaring entities like us. Their discrete nature, unless they're the size of asteroids, means stumbling upon one within our solar system would be akin to finding a needle in a colossal haystack. Even if hundreds exist from various civilizations in the vastness of our system, it might take centuries before encountering the first one. In essence, perhaps there isn't an inherent paradox, rather, our knowledge of what to seek and how to seek it remains limited. Yet, once we refine our search methodologies, the revelations might be closer and more astonishing than anticipated. Since the inception of the query, are we alone? Thanks for listening.